Alright, so we were talking about these GPT papers. Today we are going to talk about GPT-2. Date is 02/04/24 and we are going to talk about GPT-2. The title of the paper is, so I will write it explicitly here. Okay, you decode this title, meanwhile I write the name of the authors. So, okay, I will just read them. Alec Redford, Jeffrey Wu, Riven Child, David Luan, Dario Amodei and Ilya Sutskever. Okay. So, the purpose of writing this title is, how many of you can decode what does it mean? Where are the others? Tanishka and they have not returned from holidays or what? Chalo, anyway. So, language models are unsupervised multitask learners. What does it mean? How do you decode this? So, right. So, first thing is it's a language model. That means we are just going to predict next word. That is what the task is, more or less. Right? What else? Unsupervised. Unsupervised multitask learners. Right. So, multitask means you can talk about question answering, you can talk about summarization, for example, you can talk about NER, you can talk about so many other different natural language tasks, right. So, unsupervised multitask learners, we do not need to decode that much, but language models are unsupervised multitask learners. What was the takeaway from GPT-1? See, we are not there at ChatGPT yet. What is missing? And as we keep on studying from GPT-1 to GPT-2, GPT-2 to GPT-3 and so on, our understanding of why they work so well, it starts actually diminishing, right. They are more surprising than how can they work so well. So, neural networks are already very difficult to explain. These large language models are even more so. Unsupervised. So, how did you use? So, let me just take out the important points from the abstract. So, things are without any explicit supervision. okay, and they actually create a new data set. And they finally suggest that there is a promising path towards building language processing systems which learn to perform tasks from their naturally occurring demonstrations. So, language models are unsupervised multitask learners. You do not really explicitly supervise them for a given task without any explicit supervision. So, if you want, you may open this language models are unsupervised multitask learners in your devices. Okay. So, this is a very well known data set now. This is so what was the takeaway of GPT-1? Right. So, one line takeaway of GPT-1 was you pre-train the model on a language modeling task, right, and then fine tune it for the specific tasks. They are moving in this direction. So, as they write it in the paper, in the introduction, first paragraph, current systems are better characterized as narrow experts rather than competent generalists. What does that mean? Because you will create a different data set for question answering. Train your model specifically for that. So, you will have an input, you will have a curated specific output labeled, which is expensive. Expensive, why expensive? See, creating a data set, for example, for summarization, right, it is a big deal. There will be a big document, somebody will have to write the summary for it, then you give input in your that particular specialized architecture, you will put document as the input and your summary will be the label, right. You train for hundreds of thousands of such examples and your system learns to do just one thing, that is called summarization. GPT authors are moving in this direction, that in GPT-1 we showed that you what do? You pre-train on just language modeling. So, you do not really need to have any labeled data set, right, any piece of text will do, then you fine tune. Slowly they start moving from that direction also. They are saying we do not even want to fine tune. You just do one thing which is called language modeling, and this should be able to help you learn do other tasks too, right. So, the title says language models are unsupervised multitask learners. That means you just do language modeling and your model will be automatically able to learn to do these tasks. And unsupervised because they do not explicitly train or fine tune on any of these data sets like we did this in GPT-1. So, you may write this down, no explicit fine tuning is going on here, just one training, which is you train for language modeling, and that is it. So, the dominant approach to creating ML systems is to collect a data set of training examples, demonstrating correct behavior for a desired task, train a system to imitate these behaviors, and then test its performance on independent and identically distributed held out examples. What does this last line mean? Independent and identically distributed held out examples. Where do you draw your training data set from? When you are doing supervised learning, where do you draw your training data set from? So let's say you have collected a whole lot of 100k examples of whatever, summarization, question answer, whichever you choose. Okay. Now, where will you draw your training data set from? This same 100k, you will randomly sample, let's say 80k, and then you will keep 20k for testing. Or do you do it this way, that you use all 100k for training and then go and create a separate data set for test? Which one do you do? We always do the first one, right? Because we want our training data set to come from the same distribution as test data set. This is again one of the fundamental takeaways of machine learning. Your machine learning model, at least the way we know them today, they will not work fine if you train it on one distribution, test it for another distribution. A better example of this can be, for example, if you train on very low resolution images, if you train it on very high resolution images and during test time you start giving very low resolution images, the performance will not be same. Okay. So then they continue, our suspicion is that the prevalence of a single task training on single domain data set is a major contributor to the lack of generalization observed in the current systems, because for every problem you create a data set, you create hundreds of thousands of examples, you create a particular architecture suited to solve only that problem. This whole thing is hindering the path to make generalized models. The models which are trained on just one task and are able to do a lot of other tasks. Okay. So then they actually cite a different paper. I'll just read out the paper citation. So the name of the paper is, you may write it down if you want, The Natural Language Decathlon, Multitask Learning as a Question Answering, right. This was written by Mecken, Kesker and Richard Schosser. Okay. So coming back to this, so the current best performing systems on language task utilize a combination of pre-training and supervised fine tuning. We have seen this for two architectures. Which were they? GPT-1 trained on one task, but you fine tune it for others. What was BERT doing? You train it for one task or a couple of tasks. What were they? Mask language modeling and the next sentence prediction. Okay. And then you fine tune it to do other tasks too. But both are different class of models. One is encoder only, another one is decoder only. Okay. All right. So in GPT-2 they say, in this paper we connect these two lines of works and continue the trend to more general methods of transfer. We demonstrate language models can perform downstream tasks in zero-shot setting without any parameter or architecture modification. What does this line mean now? I repeat. So everybody listens. In this paper, we connect these two lines of work and continue the trend of more general methods of transfer. Right? So you may ignore this line if you wish. Important is this. We demonstrate language models can perform downstream tasks in zero-shot setting without any parameter or architecture modification. So downstream tasks basically means these guys. This guy. So you just train on one thing, right? You basically pre-train and you don't do any fine tuning. Whatever task you will give me later. Downstream means once I am done and whatever you ask me later, right? So we demonstrate language models can perform downstream tasks in zero shot setting. What is zero shot? So, terminologies like zero shot, few shot, and the third thing that we were doing in GPT-1, what was that? Now, how are these things related? And finally, you can do, so I'll just write it here for the sake of completeness. Full architecture for a particular NLP problem. You want to go from this direction to this direction, and this is what actually GPT papers are doing. So earlier there was a full architecture for one example question answering. You have thousands of examples, hundreds of thousands of examples, train a particular network for it and get whatever results you are getting. GPT-1 BERT comes and say just pre-train it for the task that we are saying. In one case it is language modeling, in another case it is mask language modeling and next sentence prediction. There are papers that say that this NSP task is bogus, you do not really need to do this. So later papers actually drop this next sentence prediction thing. So that means again language modeling is a very powerful task. So you train for language modeling, and fine tune it on others. So you are still feeding it the other examples, right? Maybe here let us say if you require, I don't know, 100k examples, here you won't require 100k, maybe 10k will do. Okay. Now when you come, so again names have changed but things are same. What will few shot mean? You don't fine tune as much, so you don't probably need 100k examples, but you still need something like, I mean let us say throw a number 100k, 100, 40, 50, somewhat, but much lesser than this, and this guy is much lesser than this. Okay. And zero shot means zero explicit examples. And this is what actually more or less ChatGPT kind of systems achieve, right? They were not trained on, you know, summarization explicitly, question answering explicitly, but it is able to do all these tasks properly. All right, so now we see the paper is not that much technical and we'll see it. So see, we go to their approach now. They say learning to perform a single task can be expressed in a probabilistic framework estimating a conditional distribution. So this is what we have been doing throughout machine learning. This is what our model learns basically. This is what we have been doing, whether you talk about cat recognition, whether you talk about whatever vision problem, whether you talk about whichever problem. We are given some input and our model will give you some probability of the output, right? If it's a binary class, then you will have simple probability assigned to one class. If it's a multi-class problem, then you will have, which activation function will you use in case of multi-class? Softmax. So you can use softmax here, but eventually this is what all these models are trying to achieve. Now, they come and say that we need to improve on this. So, this is again an important thing. They say it should be, so if we want our system to generalize well, we should be able to do things like this. So, we should be able to this is American English or S is American English? This is American? Okay. So, what do you want? What should I write here? See, until now you have been doing, so let's say if you are talking about question answering, if you are talking about summarization, what will be input? The big text. What will be the output? Summary. And where is this probability coming from? No. So, can I assign probabilities even in the summary? How can? Because whatever sentence I am generating it with some probability. I could have generated something else as well. Okay. So, to generalize, what should happen? I should compute probability of output given. So, right now this is, so let me help you. Right now this is task specific. Right now this is task specific, right? I want to accommodate task where, see, this is the probably the summary of the whole paper, or at least if you have two takeaways, this is one of them. Now you have everything. What should I write here? See, earlier you are making your models that take some input, give you some output, and your architecture is task specific. If you are summarizing, architecture is just focusing on summarizing. If you are doing named entity recognition, your architecture is specialized to named entity recognition. For every word you are going to say 1 or 0, and so on. So, in this sentence we have three things embedded: input, output, and the task. And who captures the task? My model. That this is my model that does summarization, this is my another model that does translation, this is my another model that does NER, and so on. What they want to say is it should be this way: compute output given input and task, right? So, their claim is we want to do this. Until now, machine learning, the way it is done, at least for natural language processing, so we are very specific to natural language processing right now, no vision here or not even speech. In fact, speech can come here, that is more or less same like NLP. Output, so input is given to me, I will give you the output probability, but which task I am doing, it is captured by my network. Right? So, this is their first hypothesis that they want to test. And then they finally say, we demonstrate that this approach shows potential by highlighting the ability of language models to perform a wide range of tasks in a zero-shot setting, right? So, they want to test this hypothesis whether this can be done, and they say that actually we were able to demonstrate something of that sort. So, we achieve promising, competitive and state of the art results depending on the task. Yes. क्या चीज? We'll talk about that. Okay. So, um, now approach is what? Language modeling. They want to do it through language modeling, just one task. Yes. We are saying this is the direction we want to take, okay, and right now we are saying the current models are not able to generalize well across tasks. See, there can be generalizations at multiple levels. When we talk about generalization of a summarization task, what do we mean? I should be able to do well on unseen data, right, unseen examples. Here we are going much, a level up now. We are saying we should be able to generalize on the task, not just example. Examples of course we should, but we should be able to generalize well on task as well. I train for one task, but I am able to solve the problems belonging to other tasks. So, again the other paper that I had quoted here, they say that language provides a flexible way to specify task, input and output all in a sequence of symbols. For example, translation training example can be written as a sequence. Now, these are hypotheses, right? So, translate to French, so what they are saying is, the good thing with language is everything can be, every problem that you are citing can be written as a, in form of a language itself, including, so when you want to translate, you can write this in a piece of text by saying translate to French, you provide English text and you provide French text. There is no reason why should this work, right? So, if you are thinking why should this work, there is no reason why should this work, but they demonstrate that this works. So, all speculations that we had before whether this should work or this should not work, they go away because they show that this works. You can't mathematically prove that this works. There is only one way to prove it. Go and train it. So, language modeling is also able to learn the, so that is what we are saying. Language modeling, once you train on language model, you do not really need to explicitly train it for the other tasks that they talk about. Preliminary experiments confirmed that sufficiently large language models, you may write this down, sufficiently large language models are able to perform multitask learning by this setup, but learning is much slower than in explicitly supervised approaches. So, what does this statement say? First of all, primary experiments. So, they infer, there is no concrete result. So, preliminary experiments confirmed. Second, sufficiently large language models. So, let me write these down. Second is sufficiently large language models. These 4 lines, they are probably the summary of GPT-2 paper. Okay. These are preliminary results, so they are not able to show that they outperform the state of the art results on all these problems. What they are able to demonstrate is that the large language models, when they are sufficiently large, right, they are able to perform multitask learning. You train it on just language model and they will be able to perform question answering, summarization, NER and so on. Are they able to beat the state of the art models designed explicitly to do that? No. Okay. So, learning is much slower compared to explicitly supervised approaches. Now, and see, this is the beauty. So, what they do is they create a new data set to do this. This is huge. So, they call it, what was the name of the data set? I just wrote it above somewhere. Web text. Okay. Now, so what they do is they crawl Reddit. Okay. ये ना सही स्पेलिंग है ना भाई, या RA होना चाहिए था, सही है? Okay. हाँ? No. So all those outbound links from Reddit, so maybe okay, that was not the right thing. So outbound links on Reddit with greater than or equal to 3 karmas. I have no idea what are they. Okay, but it seems like that upvote, like those kind of things. Okay, so outbound links on Reddit with greater than 3 karmas. So they go through some 45 million links, right, and they take a subset of it and they claim this is very high quality data. Right. So this finally gives them slightly over 8 million documents with a total of 40 GB of text. 8 million documents, roughly 40 GB of text. And this is again, so they removed all Wikipedia documents from web text. So maybe I should write this down. Right. So why do you think they would like to remove all the Wikipedia documents? Reddit is. So Wikipedia is not reliable, but Reddit is. See, Wikipedia, when you say Wikipedia is not reliable, it is not reliable to be cited as a as the only reference, right? Wikipedia is a very good first place to start, and then go to references that are more authentic, where you can cite the author, where you can cite the papers and so on. But Wikipedia is reasonably reliable, much more. So I would rely on Wikipedia much more than, let's say, any of the news channels these days, right? So remove all Wikipedia docs from web text. They do this because another data set called Common Call and all this, they hugely rely on Wikipedia. So they say, see, this is again, I mean, you can't stop. So they create this data set, and then they are going to evaluate their work for other data sets on which they have not trained, because otherwise it wouldn't make sense. So if they train on all the existing data sets, then claiming this title. So what is the title? Language models are unsupervised multitask learners. If you also take, summarization data here, if you also take the squared question answering data set here, if you also take NER data set here, if you take all the other data sets here, then you are actually training your model on those data sets too. And now you come to me and tell, see, my model has been able to learn question answering, summarization. Of course it will, because your training data had those examples. Right now they are saying we don't feed any explicit specialized data set to our language model. We feed just this 40 GB of text that they filter by making only high quality documents, and this is where, this is the start of it, at a bit digression from here, but this is the start of the NYT lawsuit on OpenAI, because they say high quality, high quality, high quality. You go and look at the data set, if I'm not wrong, either 4% or 22% of this data set is basically NYT articles. Okay? So NYT claims that OpenAI on the one hand says they rely on our data because it is high quality. At the same time, they don't want to pay us any kind of royalty, they want to free ride, right? So that was the start of this lawsuit as well. Now, so I posted some question, somebody comes and posts some answers and links to a document. So those documents, because then they are fairly understood as, some reliable sources, because what I write, forget that, because that might be junk. But if I give you some link where you can refer something, that is like more reliable. Okay, so we are more or less done with GPT-2, because what remains is something you already know. So give me the architecture. So how will they format the input? How will they prepare the vocabulary? That is tokenization. I have told you before. Tokenization used in GPTs are BPE. Okay. What is the full form of BPE? Byte pair encoding. So even though they don't do byte pairing, but because of the legacy, the 1994 algorithm, this is still called byte pair. Vocabulary size, vocab size is 50,000 to 57. Okay. And context size is what was it for GPT-1? What was context size for GPT-1? 512. Context size is, number of inputs that I am giving, because that is the context of words that I am providing to the model. Okay. Now GPT-2 is encoder only, encoder decoder, or decoder only? Decoder only. So decoder only model, and I am going to draw the table that they have. So parameters, layers, and D model. So I have not talked about D model until now. What is D model for GPT-1? 768. So parameters for GPT-1 were, so which one is the first line? This is basically GPT-1, because they want to compare with GPT-1. Now which model is close to this one? This is BERT large, right? Roughly 340, 24, 1024. Next will be 762M, 36, 1280, and the last one is 1542M, 48, 1600. This is what they call GPT-2. No, so third one, so this was BERT large, but this one they are, so this was GPT-1 to compare with GPT-1, this was to compare with BERT, but now what they are having is their own things. So this is not, with comparison, this is not to compare with any other model. And this basically is the first model of that size, non-sparse, first non-sparse model of size. So, this is 1.5 billion now. If D model is 768, number of attention heads would be, assuming that my one head is 64, and you can see, so what will be here? 40 heads. Okay. So, if you see, the only difference that we see in transformers all the way until GPT-2 until now is you just change these numbers, you drop either decoder or encoder, but in GPTs you are dropping encoders. So, these are all decoder only parameters, I mean models. No, but GPTs are all decoder only, and they are all decoder only. They are keeping these parameters to be able to compare with GPT-1 and BERT, right. So, if they want to compare with performance of BERT on something, they will compare it with this one and not with this one, for example, because you can't compare two models that have almost 10 orders of magnitude difference. In this case, this is at least 5 times that one, right. So, vocabulary size is done. How would you create that vocabulary? Okay, and a larger batch size. So, batch size is 512. And then they are able to show that this works really well, and they basically validate these claims that they had before, that this is what we want to do. So, even though these are preliminary experiments, they are still able to perform multitask learning. Sufficiently large language models, one topic is remaining, I will come back to that, and learning is much slower because you have so many parameters. Leave it. Okay, I have it. क्या बोल रहे हो? Okay, this is okay. So, last thing, this is figure 4 of the paper. So, this is perplexity. This is model size, and model size started from 117M, 345, 762, all are in millions, 1542. So, I will just write. Okay, and this is like 2, 4, 6, 8, 10, 12, 14, 16. So, they show that something like this happens. So which one should be the, so this is their training curve, which data set? Web text, and this is their test. Anybody heard of Perplexity? I mean not perplexity.ai, but perplexity as a metric. So right now we'll just say the lower the better. They conclude this paper and this lays the foundation for, this lays down the foundation for GPT-3. They conclude this by saying, so what do we usually expect in a training? What will happen in the end? In the end, my models will kind of flat out, right? Remember those 4 lines, what were they? Until convergence, compute J, compute grad J, update W's. Until convergence. What does until convergence mean here? Means you stop updating, you stop learning. If you see here, it is still decreasing. Lower perplexity is better. So has it flattened out? Not yet. So then they come and say, see 1.5 billion is not sufficient, we need to train even larger models. So what do they do with GPT-3? What is the size of GPT-3? 175 billion, okay, and this is where they required 10 billion from Microsoft, okay. So that is it. Just wanted to show one thing, I don't know what. यार इतना सा लिखते ही, so I wanted to take you back somewhere. What were the four summaries that I had written? First was preliminary experiment. So they are able to show that this multitasking actually works. Second was sufficiently large language model. They say sufficiently large because even 1.5 billion are not sufficient, we need to scale it more. What was the next? Perform multitask learning, they are able to do. And last thing was? Right. Okay. And what do you think they will do in GPT-3? By now you should be able to guess. So how will you make it 175 billion? What will, I mean, I'm not looking for exact numbers, but what will you do? What will you do? So you will increase vocabulary size. So GPT-3, I think it has somewhere around 100K. Use BPE again. And what do you do here? Change these, I mean, the moment you do 100K, right, you've already increased a lot of parameters, but that only kind of doubles it. You still need to do a lot more. Okay, so that's it for GPT-2. Done for today.